Welcome back, everybody. So in this video, I'm just going to explain what I would like you to do next. I'm going to get you to do a little bit of work. I basically want you to fill out this table here, key terminology for circuits, part 1. So if you're watching this video, that means you found this lesson on Google Classroom. And if you follow the instructions, you should have already opened this file. Every student in the class has a copy of this file, and whatever you type in it, that's your own notes. And I'll be able to see it as well. And I want to be able to check in on you guys to see how you're doing, how you're understanding this work. So a lot of the words here are terms that I've talked about in the previous couple of videos, in the previous couple of lessons. Not all of them. There are a couple of new ones, such as switch and resistor. I'll talk about those a little bit today. But otherwise, I'm hoping all of the other words on this list are familiar to you. So what I would like you to do is type out a note for yourself for every one of these words. 1 or 2 sentences. It doesn't have to be very long. For example, power source. What is a power source? How does it relate to circuits? Just type 1 or 2 sentences saying what you think about that. So you might say something like, it provides energy to a circuit. Okay, you may say that it applies a force to push electrons through a circuit. And these are just a couple of examples of things you might say. And then I want you to type out an example or more, if you know of more, of different power sources for electricity. So the ones that were used in previous videos were simply batteries. I don't think I've used anything else. But that's certainly not the only thing that powers circuits. When you plug things in, like my laptop here is plugged into that outlet there. So that's coming from a power plant or hydroelectric power. That could be another power source as well. So I want you to do that. So type out a note and an example for each one of these words. For the example, sometimes it might be better to put in a picture. I'm thinking about series and parallel. You can type a definition of those under the notes section, but in terms of the example, it might be best to cut and paste a picture from a previous slideshow, from a previous video, or just even from the internet. If you search on Google, you can get a picture there. All right, so once you have it all completed, then you can click Turn In on Google Classroom. And that will give me an indication that you're done. And I can open your file and I can see what you've done. I can give you feedback. And it'll also let me know that you're on track. All right. So I want to talk about these two here a little bit, switch and resistor, because I haven't yet already. So I'm going to go on to my virtual circuit construction kit. And there's a resistor right there. And there's a switch right there. I'm going to show you what they do. So I'm going to just first make a basic circuit, and then I'll add those in after so that you can see what they do. Okay, so there's a circuit, a basic circuit, and I'm hoping that you can even use the proper terminology to describe that circuit. This is a circuit that has 3 cells and 1 light bulb, all in series with each other, so they're all in one single pathway. Okay, now I'm going to add a switch to this circuit to show you what a switch does. Okay, this is a switch, and what I can do is click on it and drag it Oops, well, okay, I guess just click on it. And as you see, when I click it, the circuit turns on. I click it again, it turns off. Turns on, turns off. In real life, you would physically open and close it. Okay, there's a lever going on there. But I guess in this virtual lab, I just click it. And all it is something that can be opened and closed in order to turn a circuit on or off. Okay, so right now this switch is open. There's a gap of air here. Air is an insulator, so electricity cannot pass through there. So none of the blue dots are moving. And then I click it. Now it's closed. Okay, everything's connected. The switch is closed. The circuit has turned on again. Okay, so that's what a switch does. Okay, it's something that you can open or close to allow electricity to flow through a part of a circuit or not. I'm going to now turn this into a parallel circuit by adding more wires and another light bulb. Okay, and now you see that one of the light bulbs is on, but the other light bulb is not on. That's the light bulb that is not on has a switch in series with it, and the switch is open. When I close that switch, now that light bulb turns on. Now they're both on. Okay, so this switch can control whether or not the one light bulb receives electricity, but this switch does not affect the other light bulb. I can give the other light bulb its own switch. I'll do that now. So I add some more wires, and I put a switch in to this other pathway. There we go. Now both light bulbs have their own switch. I can close the switch, it'll turn on that light bulb, and I can open it. A very simple example in the house. I'm not near one right now, but just light switches, right? Light switches, that's what happens. You turn it off and you turn it on. Now, finally, I'm going to add one more switch in here, but pay careful attention to where I put it. See, I'm putting the switch, I guess I'll say it's close to the batteries, but I'm putting it along a pathway. I'm putting it along part of a pathway so that it can actually cut off electricity to both light bulbs at the same time. So first I'll close all the switches, so allow electricity to go through everything. Now this last switch I added, watch what happens when I open it. See, I open that one switch and the whole thing stops. Both light bulbs stops because I cut off the flow right there. So if the blue dots start at the battery and they go through the wires and then they get to this gap, now it can't go anymore, it can't flow anymore. So it cannot get to either of the light bulbs. Okay, so the placement of the switch is really important on whether you want it to control one light bulb or the other light bulb or all the light bulbs together. Okay, and that's a switch. Okay, I'm going to simplify the circuit here, get rid of some stuff, and then I'll talk about a resistor, and that'll be the last thing. You might hear the fan going on my laptop because running this program and the webcam at the same time is making it work really hard. All right. Let's throw in a resistor. And I wonder if you noticed what that did. It just looks like a regular circuit. There's a light bulb, the light bulb's on. But I want you to pay attention to how fast the electrons are moving. And then I'm going to take the resistor away and see if you can compare how fast the electrons are going then. So now without the resistor, so you may have noticed that the electrons are going much faster and that the light bulb is brighter. Okay, so basically what a resistor does, I'll throw it in again. A resistor essentially just slows down the electrons, or it resists the flow of the electrons through the circuit. And that's going to take away some of their energy, and that's why the light bulb is less bright, because the resistor is taking away some of the energy. You need resistors in really complicated circuits to kind of control the flow of electricity, because in a complicated device, you've got electricity flowing to this component, to that component, to all these different components. Maybe some components need the electrons to go fast, and other components need the electrons to go slow. So then you put resistors in different parts of the machine to make the electrons go faster or slower in different parts of the circuit, so that the components can receive different amounts of energy. All right, so that's it for the new stuff. And just a reminder, your task for this lesson is to get this table filled out. Okay, write a note for all of these terms. Get an example or more down for all of these terms. And then once you're done, click Turn In on Google Classroom so I can read your work and give you feedback. All right, hope you're staying safe, hope you're doing well, and we'll see you next time.